Hello again, everyone. Let's see, in this week's critical thinking exercise, we are asked to calculate some confidence intervals about some means and also about some proportions that we're going to calculate. Let's see, we're looking at our shopping mall data and we're looking at variables 7, 8, and 9. And as you recall, back in Chapter 2, if you don't, Chapter 2, and I've got it marked, it's page 55. Those are columns where we're looking at general attitudes towards the malls. And the values in these columns, the three columns, 7, 8, 9, are for the three different malls. And the values within range from 1 to 5, 1 being dislike very much, and 5 being like very much. Well, we've dealt with this data before. But today we're going to do something different. We are going to calculate confidence intervals. What we're going to do is calculate a range of numbers. We're going to calculate the mean, and then we're going to calculate a range around that mean. That is our confidence interval, and we're going to be able to say that we are 95% confident that the true population mean is within that interval. Okay, so let's see. Let me check something. I've decided I'm not going to use variables, whatever they are, 7, 8, and 9. I don't want to give you the exact answers. No biggie. I'm going to use column 1. And in column 1, let's see, that is how often respondents shop at the areas, and that's the values for the Springdale Mall, and they range from, the responses range from 1 to 6, 1 being they shop 6 times or more per week, and 6 being 0 to 1 times per month. Now, it doesn't really matter what we're measuring. What counts is that we're constructing a confidence interval on the mean of those values. So values range from 1 to 6. First thing we need to do is calculate a mean. In our critical thinking task, in number 1A, our author asks us to determine a point estimate, then construct the 95% confidence interval for the population mean. So what is this point estimate? Well, that's another way of saying estimate the mean as best as you can. Well, from our data, all we can do is calculate a mean from our sample data. That will be our point estimate. Okay, so let's hold on a second. I got to pull up my spreadsheet here. It's pretty goofy that I tell you to hold on, isn't it? But I never remember that when I'm doing this. Okay, so our data, again, we're going to look at Springfield, and in column 1, and you can see the values range from 1 to 6. First of all, what we need to do is estimate the mean. The mean and the sample standard deviation. So the sample mean and the sample standard deviation. And then from that, we are going to calculate the confidence interval. But first we need the mean and the sample standard deviation. How do we do that? Well, let's see. You could just use Excel's functions if you want to do that. Sure, that will work. I'm going to, let's see, we used a histogram function, right? Let's see, let's try that. Data, was it in data analysis? Yes, it was. Histogram input range. I'm going to go over to column 1, grab my data as input to the histogram. Come on. Yes, I have labels. Ooh, I need a bin range. Am I doing this right? No, I want descriptive statistics. I want an average and a standard deviation. Okay. Sorry about that. Let's back up. Let's cancel that. Let's go to, where is descriptive statistics? I believe that one was in our data no, descriptive statistics were in the data analysis plus. That's our add-in. So I'm going nuts. Okay, I'm nuts. Let's try again. Add-ins, data analysis plus. No, you were just there, Craig. Try it again. Data analysis. There it is, descriptive statistics. Okay, I need my data range once again, so I'll grab column 1. You guys aren't doing column 1, but I am for the show and tell here. Oh, come on, there we go. And let's see, labels in first row, put it in a new worksheet. I want summary statistics, go. And there is my data. And let's see. What have we got? We've got a mean of 4.49 and a standard deviation of 1.28. Hold on a second. I'm going to write those down. We are now ready to calculate the confidence interval. We have our sample mean and our sample standard deviation. All we need is the right equation. Now recall, we never have the population mean. It's rare that we would ever have that. We draw a sample and we calculate an estimate of the population mean. That's our sample mean, but we don't have the population mean. We're going to create a confidence interval once again and say that we are 95% confident that the population mean falls within this range. Okay, do we have the population standard deviation? Remember in my first lecture, my first video this week, I said that sometimes we do and sometimes we don't, although it's rare that we do. Well, we're not that rare case. We do not have the population standard deviation, but we do have the sample standard deviation. Okay, so now we are ready to use the equation on page 284 and calculate that confidence interval. The equation looks like this. We can calculate the confidence interval by taking our mean, adding the t-score times sample standard deviation divided by n, the number of samples. So for our case, we would take 4.49 plus or minus t. Well, how do we look up t? If you check in the back of your text, we have a table of students' t statistic, and it works a little bit different. We need degrees of freedom. And let's see. Degrees of freedom, the author describes what it means, and it's one of those weird statistics things that I don't even want to tackle, but it's always equal to n minus 1. So for our case, our n, we have 150 samples, you subtract 1, and our degrees of freedom is 149. So when you look at the t-table, you will find that it doesn't go up to 149, it goes up to 100. Well, what we do then is use the infinity row. And the infinity row happens to be the same as the z-score, the z-statistic table. Now, okay, but so what do? The t-score is a one-ended score, whereas the z-score has confidence interval has a portion on each end, but the t-score has it only at one end. We are looking for the 95% confident interval, so we look under 0.25, and we find our t-statistic happens to be 1.96. Now, on page 277 in your text, you will find z-scores that should be used based on the most common probability levels, 90, 95. However, you can always use the t-table or the z-table if you have a high number, if n is large, over 100, and figure out what that value is for other confidence levels. We're going to keep it simple. We're going to usually do a 95% confidence level, and for that, if our sample size is large, over 100, our t is the same as the z value of 1.96. Okay, multiply this by standard deviation, 1.28, and divide by the square root of n being 150. And now I'm going to do some math. I'll be with you in a second. I've run the numbers through my calculator, and I found that our confidence interval can be listed as I've shown here, 4.49 plus or minus 0.205. 0.205, I simply multiplied 1.96 times 1.28 and divided by the square root of 150. So, what is my confidence interval? Well, all I need to do is add or subtract 0.205 from 4.49, so I'll do that. 4.49 minus 0.205 is equal to 4.29. And on the high end, we have 4.49 plus 0.205, and that equals 4.695. That would be 4.70. Voila! There's our confidence interval. We are 95% confident that the population mean falls within the range 4.29 to 4.7. We are estimating our population mean with a sample mean, and that is equal to 4.49. That's it. It's that simple. Now, these equations are not difficult, and you can, aside from getting the sample mean and sample standard deviation, it's a simple calculation. However, data analysis package, whatever we call it, will do it for us. Here's how. I need to add in our data analysis plus, and I got to choose the right one here. It is t-estimate mean. So here is t-estimate mean. I'll say OK. And of course, he wants a range of data, and I'm going to choose that range. I'm doing column 1. You're not doing column 1, right? Here's our alpha level. We said we wanted the 95% confident level. That means we put 0.05. Yes, we have labels. Now, this is going to give me the confidence interval. I believe our discussion question this week talked about different confidence levels and what that might do to the confidence interval. Asked what the confidence level, be it 0.8, 0.9, 0.95, what that will do to the confidence interval. Well, here's a way, by manipulating that 0.05, you can figure it out with some numbers. Okay, let's see. Let's finish this off and see if I did the calculations right by hand. Ooh, I did good. Yes. Here it is. It calculated, oh boy, our mean and our standard deviation. Yep, they're still 4.49 and 1.28. Let me just shrink these up a little bit for you. LLC, lower confidence level, UCL, upper confidence level. I imagine that's what they mean. And sure enough, have the same values as I did. Our confidence interval ranges from 4.29 to 4.70, and our estimate of the population mean is 4.49. Okay, let's jump back. No, not there. Where am I going? Here. Let's jump back and look at our equation that we used here. I would like you this week to do more than just report figures. I would like you to do some further thinking and analysis in the paper that you write for me. The calculations are simple that we've done, right? You can do them by hand if you want to. What I want you to think about is these confidence intervals and what affects the size of the confidence interval. Now, this could be a little discussion in your discussion and analysis section or something like that. What do we have? We have the mean, and the part that creates the confidence interval is the t-statistic times standard deviation divided by the square root of n. So, you can talk about these three values. Where does t come from? Well, it comes from our confidence level and also our degrees of freedom. Where does s come from? Standard deviation. Well, that's a function of our sample. And where does n come from? Well, that's our sample size. So you might talk about how sample size influences the width of the confidence interval. You might talk about how a large or small standard deviation influences the size or the width of the confidence interval. You might talk about the student's t-score and how it influences the size of the confidence interval. I'm hoping that you'll do that for me. Okay, let's see. We've got another problem to do. We're up to 16 minutes. Let's make this one go quick. Let me get ready. All right. The preceding discussion will get you through problem 1, parts A, B, and C. You're just doing the 3 moles, or I guess it's part A and B. In problems 2 and 3, we are looking for a point estimate and 95% confidence intervals for a population proportion. Now, what are we talking about? Let's see. The one they want you to do first of all, is the proportion of males in our sample. Now, we have a gender column, right? Gender column is column 26, and the values are either 1 or 2, male or female. And so, because it's that binary sort of thing, male or female, 1 or 2, we are going to calculate a simple proportion, the proportion of males, and construct a confidence interval around that proportion. All right, so I'm going to do something a little bit different. I'm not going to calculate it by hand for you this time, although you certainly can. I'm going to jump over to my Excel spreadsheet, and I've created another set of data here that I'm going to do. Now, you're going to do both gender in problem 2 and marital status in problem 3. And but let's see, I'm going to look at eye color. And so I've just made up some data here, and I am going to calculate, this time we need something called the Z interval for proportion, and you'll find this on pages 288, 289 in your text. Here I am drawing on the whiteboard, and you're looking at my spreadsheet. It's okay. We'll come back to the spreadsheet. All right, so what I need to do is, first of all, I need to use my Data Analysis Plus. And this time, I need my Z estimate proportion. Let me double check that again. Yes, that's the right one, Z estimate proportion. We say OK. Again, we need a range, and I'm going to use that range. Yes, I have labels. Code for success. This goes back to our binary distribution and success or lack of success when we were dealing with proportions in chapters 4 or 5. Let's see, our alpha level is 0.05. That is correct. And so I say OK. And up pops my z-estimate proportion. It says our proportion is 0.667. And we had 27 observations. And if we look back at that data, sure enough, I counted there's 27 and 18, or 2/3 of them, are 1. And so, yes, the proportion is 0.667. And here's our upper and lower confidence levels. And I'm going to write that down. Let's see. Probability or proportion is 0.667. And our confidence interval is 0. I'll come back to my whiteboard in just a minute. Let's round it. Let's call it 489 to 845. Okay, it was that simple. Oops, come back here. So sure enough, we could have used our equation and calculated the same thing. How would we do that? Well, we would need to have that proportion, and we could have done that in Excel, or we could have used, let's see, our histogram would have given us the frequency distribution, right? That would have worked. So, am I right there? Yes, it counts up the numbers of 1s and 2s. We'd need that little bin table to go along with it. So we would have calculated this 0.677 plus or minus our z statistic, and for the 95% confidence level, z is 1.96, times the square root of p 0.667. Oh, running out of room. 0.667 times 1 minus 0.667 all over the square root of n. We had, well, let's see, in my case, we only had 27 values. You'll have 150. But if you do this math, you should get the same thing I have here. What does this tell us? Well, this is our confidence interval on a particular proportion. And this is the proportion of males. No, this is the proportion of blue-eyed people in my survey. When you do it, you're going to be looking at both gender, and then what's the other one? Marital status. And you'll be making confidence intervals about those parameters. All right, that does it for us. Another long video. I hope this has helped. Call with any questions.